In this video, we're going to talk about what the first derivative shows, which will be our maximum and minimum points. Let's start. The first derivative, whenever we take it, the x-intercept of the first derivative are the stationary points of the original function. Now, what does that mean? Well, it means that when the first derivative is negative, our original function is decreasing. And we can see that when we first talked about derivatives together, we chose any random point on our original function, and we saw the original function at this point is clearly decreasing. Therefore, the tangent line has a negative slope. So if our function is decreasing, then that means that our derivative, our slope of the tangent line, is negative. So this is what we need to understand when we have a decreasing function, our derivative is going to be negative. And same is true if we have an increasing function, then our derivative is going to be positive. And this is the basis of understanding the derivatives. So at any point along, for example, here, we see that my function itself is increasing. Therefore, the tangent that I would draw, it's not a great tangent, is a positive slope. So the derivative would be positive for an increasing function. Good. Now, what happens if our function is not decreasing or increasing? Well, we get these points. So we have point A, point B, and point C. All of these points are what we call stationary points. It's points where there's a clear switch in either increasing or decreasing, or simply in this situation, there's a switch in concavity. So which way the function is kind of pointing. And we're going to label each of these points. First, if we look at point A is what we would call our minimum point. So the minimum point, or local minimum, is going to be our point A. And this happens when we go from a function that is decreasing, and then after point A, we have a function that's increasing. Now, this is about the function. If we think about what's happening for our derivative, well, our derivative would go as a negative derivative. After point A, it would become a positive derivative. And this is what would be happening to our derivative function. If we skip and go to point C next, point C would be considered a maximum point. And for a maximum point, it's the opposite of what we have for point A. Instead of being decreasing first, our function starts by being increasing, and then at our point, we are going to be decreasing afterwards. And therefore, for the derivative function, we're going to be positive to start with and then negative after this point. And the last point we're going to talk about is this point B. Now, this point B, notice that our function is increasing both before and after point B. But the tangent line at point B is clearly horizontal. Now, this is called an inflection point. So it's either when your function is increasing after this point, it's actually still increasing. So the derivative is always positive before and after, or you could see the other way happening. If it's decreasing after point B, it's still decreasing. What's happening at our inflection point is that we have a change in what's called concavity. So this part here is what we call concave down because it seems to be kind of pointing downwards, while on the other side it's kind of concave up because it seems to be pointing upwards. In the SL curriculum, we are not going to calculate inflection points, but we just need to have a general understanding of what they are and the fact that they exist. If you would like to know when inflection point happens, we need to take what's called the second derivative, which is not in our course. So if we kind of do a little summary of what we just talked about, is we talked about what are called stationary points. Stationary points is when our derivative, our first derivative, which is what we're doing all the time in this course, is equal to 0. So we're asking yourself, when is the first derivative equal to 0? And that's the same thing as saying the x-intercepts of the first derivative, right? So we're looking at when is our first derivative equal to 0? We're going to get some x values, and those are going to be when we're going to have a horizontal tangent. At these points, we can either have a minimum, a maximum, or an inflection point, which we're going to figure out by using our derivative. So looking at the sign of the derivative, we are going to know if we have a maximum, minimum, or inflection point. Let's look at an example. If I have the following cubic function, which I graphed on the left side, then I can find what my minimum and maximum points are. So in our calculator, we can do second function trace, intercepts, and we'll get that our maximum and minimum points are the following. So the minimum point happens at negative 0.5477, and our maximum point happens at positive 0.577. Now let's try and understand what is happening to our function and therefore determine what is happening to the derivative. In this situation, my function is decreasing from, if looking at the domain, it's decreasing from negative infinity all the way to negative 0.577. Then from negative 0.577 to 0.577, it's increasing, and then it's decreasing again. So there's two parts in which we're decreasing. So we're decreasing all the way here, and then we're decreasing here as well, and until infinity. Now let's think about the first derivative. So if we have the derivative of this, well, we're going to have the derivative is negative 6x squared plus 2. Well, let's graph this derivative, and let's see what it looks like. When we graph the first derivative, we notice that where our function is decreasing, which is these two sections here, the derivative function is negative at those points. So these two parts are negative because they're below the x-axis. Where my function is actually increasing, let me use purple, where my function is increasing, well, this derivative is a positive number here. And when is my derivative equal to 0? Well, my derivative is equal to 0 when I have the same x value as the minimum and the same x value as the maximum. So now we have a visual way of seeing these. What's super important is that we're going to be using this and we're going to be creating what are called sign diagrams to understand our function. So if I show you an example of that, a sign diagram is as follows. We are going to label our stationary points. We're going to label when the derivative is equal to 0. So on a number line, so this part here is a number line, I'm labeling my two stationary points, which are when the derivative is equal to 0. And then we see what is the sign of our derivative. Well, if we look at our derivative, we're going to look at the derivative function. Before is negative 0.577, my derivative is negative. After negative 0.577 and until 0.577, my derivative is positive. It's above the x-axis. And then again, it's negative after that value. Since our derivative is negative, that means that my function is decreasing. So this here represents decreasing. When my derivative is positive, my function is increasing. If my derivative is negative, then my function is decreasing. Now you're probably asking yourself, why do I need to know this? Because I have a calculator and I can always put the function in my calculator. Well, sometimes the IB will tell you the derivative is negative, and they're going to expect that you know that that means that our function is actually decreasing at that point. So we're going to need to have a good understanding of what it means for the sign of the derivative and what it means for our direction of our function. By using the derivative, find the intervals where the function is increasing or decreasing. So for A, let's find the derivative to start with. My derivative is going to be negative 3x squared plus 6x. If we graph this derivative, then we're going to figure out when it's positive or negative. So let's go ahead and graph my derivative. This is the graph of my derivative. Now we are going to figure out what our stationary points are. Stationary points means when is my derivative equal to 0. So I'm looking for the zeros in my calculator, second function, zeros. I go to the left of the 0 and I go to the right of the 0. And then I guess my first 0 happens at 0, 0. So my first stationary point. And then I repeat the process to find the second stationary point. So to the left and to the right of it, and I guess, and the second happens when x is equal to 2. And then I ask myself, what is happening to the derivative function? Is it positive, negative at those points? So at the stationary points, my derivative is equal to 0. Let's see, before 0, my derivative is negative. Between 0 and 2, my derivative is positive above the x-axis, and after 2, my derivative is negative. Therefore, this tells me that my function will be decreasing before 0, increasing between 0 and 2, and then decreasing again. Since I know that I'm going to be decreasing and then increasing, so decreasing and then increasing, this is going to be a minimum point at 0. And then for 2, I'm going to be increasing and then decreasing. Therefore, I'm going to have a maximum point at 2. So find the intervals for the following increasing and decreasing. We would say that our function is increasing from 0 to 2. And I'm actually not going to use the and equal to signs because at those values, it's neither decreasing nor increasing. And then it's decreasing when x is smaller than 0 and when x is bigger than 2. And we're going to do the same thing for the other question. So the other question, we also have a cubic. So what is the derivative of our cubic? We're going to have 12x squared minus 2x minus 4. I'm going to go ahead and graph that. And there I'm going to have my quadratic. I need to find my stationary points, so I need to find when is my derivative equal to 0. So I'm going to find these zeros, and I'm going to create a sign diagram with them. So second function trace, zeros. I'm going to have left bound and right bound. So and guess. One of my zeros happens at negative 0.5, and the other 0 and the other one happens at 0.667 or 2/3. And then for my derivative is positive before negative 0.5, negative after, between the two, and then positive again afterwards. That means that my function itself will be increasing, it will be decreasing, and then it will be increasing again. So our x is equal to negative 0.5. This is going to be increasing, then decreasing. So this is going to be a maximum point. While our x is equal to 2/3 is going to be decreasing, increasing. So that's going to be a minimum point. So doing the inequalities, my function is going to be increasing when x is smaller than negative 0.5, and it's going to be increasing again when x is bigger than 2/3, and then it's going to be decreasing between negative 0.5 and 0.667. Next example. For the next example, find and classify all stationary points of our function. I want you to try this by yourself and bring your solution to class. So you should be able to do very similar to what we just did for A and B. I want you to find the derivative, and then I want you to find your stationary points. So the stationary points, this happens when the derivative is equal to 0. And then I want you to create a sign diagram. Please bring this to class with you.